It is exactly 2 p.m. here in Malmö, Sweden. So, hello everyone, and welcome to our Knowledge for Life alumni webinar series. My name is Charlotte Wara. I am the alumni officer here at WMU, and I am excited to be your host today. Thank you all so much for being part of this session. Our topic for presentation today is on the theme, Sustainable Shipyard, Applying a Transdisciplinary Shipyard Energy Management Framework, a strategic analysis from concept to case study. We hope that you will find the presentation interesting and thought-provoking. We will have 1 hour for the presentation, where 30 minutes will be used for the presentation and 30 minutes for the Q&A session. So please feel free to submit your question using the Q&A section. Today's webinar will also be sent to all our participants, and it will be recorded on our YouTube channel in the coming weeks. So without any further ado, it is my honor to welcome our moderator for today. Over to you, Dr. Aikot Olcha.
Thank you very much, Charlotte. And good morning, good afternoon, and good evening, dear WMU alumni and ladies and gentlemen. And thank you very much for all of you being with us today. And today's webinar is all about sustainability and the shipyards. So my name is Aykut Olcher. I'm a naval architect and marine engineer. I'm holding a full professorial position at the WMU in the area of maritime energy management. And at the same time, I'm the director of the research of the university. Now, I will definitely give the floor later on to my colleagues, Professor Ballini and Captain Wahid Vakili, to introduce themselves. But let me give you a little bit background regarding our webinar today. Today's webinar, Sustainable Shipyards, arising from the need zero emission ship. If we aim and target zero emission ship, and we cannot ignore and neglect the existing of ship production. And IMO jurisdiction is covering ship design and ship operation areas, but ship production and the emissions resulting from the ship production activities are not covered by the IMO. One more time, if we target zero emission ship as an ambitious target, definitely ship production has to be part of this big picture. In this respect, we will be focusing on sustainable shipyards with 2 main pillars. One pillar is we call it clean shipyards, and the other pillar is the green shipyard, which will be definitely elaborated and thoroughly by my colleague. So hopefully today's webinar will be able to provide the insights for the green and the clean shipyards in the process of designing and developing a transdisciplinary framework for energy management in shipyard. So without further ado, I give the floor to my colleague, Assistant Professor Ballini, and then Captain Wahid Vakili, and then Captain Wahid Vakili introduction will be the starting point for our webinar. Thank you.
Thank you very much, Professor Lorce, for the presentation. I'm Fabio Ballini. I'm Assistant Professor at Maritime Energy Management Specialization. I'm myself maritime economist, and especially dealing with the port energy management, in particular in relation to energy and environmental issue. So I'm very happy and very glad to be part to this webinar, and hopefully there will be a very fruitful discussion on this very timely topic. Thank you very much. Now I give you the floor to Captain Vakili. Thank you.
Good morning, good afternoon, good evening, ladies and gentlemen. Depends where you are living in this world. By way of introduction, I'm Captain Sergey Beit, research assistant and PhD candidate at World Maritime University. I'm really grateful from the attendees that attend at this webinar. We hope that we have a great, fruitful webinar. Without any delay, I will start the presentation. The content of the presentation, which we are going to talk, is IMO response to greenhouse gas emissions, ship's life cycle, sustainable shipyard. We will talk about environmentally sustainable shipyard, the green and clean shipyard. We will talk about energy management framework and energy management system. And after that, we will show the case study and feasibility study. And in the end, we have a conclusion. But before proceeding for further slides, for your information, we have 3 sessions of polling. I will be grateful if attendees attend at these 3 sections of polling. It will help us for further analyzing our study. The IMO, which regulates international shipping, shows its commitment to reducing its footprint by introducing the IMO's first greenhouse gas emissions strategy. The strategy has 2 objectives: to reduce total annual greenhouse gas emissions by at least 50% by 2050, to reduce carbon intensity 30% by 2040, and 70% by 2050 compared to 2008, and in line with efforts to achieve zero emission industry by the end of century. The strategy divides the actions needed to achieve the targets into 3 different classes of short-term, mid-term, and long-term measures. As shown in the figure, IMO has applied multidisciplinary measures of technical, operational, and economic nature to reduce greenhouse gas emissions from the industry. EEDI and EEXI are technical measures to reduce emissions, while SIMP and enhanced SIMPs are operational measures. The third dimension is market-based measures, which are an economic perspective and take into account the carbon market, such as emission trading system and levy, that may be discussed in near future within medium-term measures. Now, as I mentioned, this is the first round of polling. I will be grateful that my colleague already shared. I will be grateful from attendees to attend at this polling. The question is, how much does shipbuilding phase contribute to life cycle CO2 emission? I would like to highlight that we are focusing about the greenhouse gas emissions, CO2 as a greenhouse gas emission. I will be grateful if participants attend to answer this question, the first question. And then the second question, yep. Yeah, our colleagues are share all 6 questions which we want you attend and answer this question. Second question is, how much does the shipbuilding phase contribute to the life cycle CO2 emission of ships? Here, focus is about air pollutant emissions, which is CO2 nominated here. Is it less than 5%, less than 5% to 20%, more than 20%? And the second option is between 5% to 20%, and the last option is more than 20%. The third question is, what is your forecast for contribution of the shipbuilding industry to air emissions in future? It will increase, it will remain constant, or it will decrease? So what is your prediction about the contribution of shipbuilding industry to air emission in the future? Do you think that it will increase, or it will remain constant, or it will decrease? I will be grateful if all attendees answer to this question, which will help us in future for our analyzing. The fourth question is, are policymakers recommended to take into account the life cycle emissions of the ship to reduce emission in order to meet the IMO's greenhouse gas emission targets? As you know, ships has 3 phases: design, construction, operation, and dismantling. Now the IMO is focused in emissions, eliminating emissions from operational phase. But what do you think? Shall IMO consider the other emissions during the construction of the ship and dismantling the ship? Although IMO is responsible for regulating international shipping, but it has aimed to reduce emissions and eliminate emissions by end of the century from the shipping industry. And in this regard, has cooperation with other stakeholders like port and consider reducing emissions from ships and ports interface. Do you think that IMO should approach the same approach and same trend regarding reducing emissions in the shipbuilding phase also? And the fifth question, is the IMO recommended to take into account the limitation of their emissions from the shipbuilding phase in the policy, as I explained? Now, in which perspective? Yes, in the short-term period. Yes, in the mid-term period. Yes, in the long-term period, or no? Again, I would like to highlight, we are asking about the IMO. Shall IMO recommend or take into account the limitation of air emissions from shipbuilding phase in the policy? Yes, in short term, yes, in mid-term, less in the long term, and no. And in the last question, are the governments, I'm again highlighting, we are talking about the state governments, recommended to take into account the air emissions from shipbuilding phase in their policies, like national determined contributions in accordance of Paris Agreement? Yes, in the short period, governments should be considered. Yes, in the medium-term period. Yes, in the long-term period, and no. The last two questions will be raised again. I mean that the fifth and sixth question will be raised at the end of the presentation, and we will compare that with how the answers has been fixed. So we will give more 30 seconds to participants to answer to these six questions. We will be grateful if you answer these six questions. That will be help us for further analyzing during our research. Okay, thank you very much. I will be grateful if it is possible, my colleague, sure. Yep. Now we continue our presentation. Ship's life cycle. The major energy consuming stages during ship's life cycle can be divided into ship design, shipbuilding, and ship operation, and ship scrapping. In addition to greenhouse gas emission produced during the operation of the ship, there exists emissions from production, maintenance, and scrapping of the ships. While in the design, operation, and scrapping cycle, there are a number of regulations adopted or implemented to reduce greenhouse gas emissions from ships, there is not such a comprehensive and effective regulation on the ship construction cycle. Studies estimated that 96% of the ship's life cycle greenhouse gas emission are produced by ship's operation, while approximately 2% are produced during shipbuilding, 1% during maintenance, and 1% during ship dismantling. While this provision, an important initial indication of the scale of greenhouse gas emissions from shipyard as a fraction of ship's life cycle, emissions are likely to be sensitive to the types of ships on which work is performed, as well as on work method used. It is clear that for fossil fuel powered ships, their operational cycle constitutes the majority of its life cycle air emissions. However, as shipping is anticipated to move toward zero carbon fuel, electricity, and using renewable energy such as solar and wind, the fraction of shipyard operation in ship's life cycle will become larger than their operational phase by the next decades. Studies shows that if a car ferry was propelled by the batteries using electricity from Norwegian electrical grid, its contribution bore a greater life cycle climate impact than its operational phase. Another example is Yara Birkeland, which has zero emission in its operational phase. However, there is not any information about emissions during ship's construction. Sustainable shipyard. Shipbuilding produces large amount of waste and pollutants that each has negative impacts on human health and environment. Shipyards must play their role and take appropriate action in mitigation of their negative impacts. To minimize such negative impacts, it is crucial that shipyards promote their sustainability and follow the sustainable concept within their portfolio. as the shipyards introduce considerable amount of pollutants to land, soil, water, and air, following the sustainable concept, could minimize the environmental and societal impact of shipyards operation. The rationale used to provide a taxonomy for environmental friendly shipyard is as follows. In this research, we divided pollutants from shipyards into two categories of waste and air emission. At the moment, there exists national and international regulation on waste disposal, water treatment, and air pollution limits from engines and boilers in the shipyards. However, the current exists no binding regulation for the maximum amount of greenhouse gas pollution emissions and air pollutant emissions permitted from individual shipyards. To achieve a sustainable shipyard, it is necessary to focus how to manage energy in the long term and how to reduce air emissions from energy sources in the shipyards. An innovative, holistic, systematic, and transdisciplinary energy management framework to extend the concept of green ship to the lifetime of the ship can assist in transition towards zero-emission ship and promote sustainability in shipyards. The shipyards that become successful in eliminating waste from their operations are called clean, and the shipyards which eliminate air emissions from their operation, as may be anticipated for future shipyards, called green shipyards. While the clean concept deals with systematic assessment of environmental aspect and impact of production and support process to mitigate pollutants and reduce their negative impacts on water, soil, and land, the green concept deals in mitigation of air emissions. The combination of both concepts leads to boost of environmental sustainability and the competitive advantage of shipyard in the competitive market. Divided to green and clean shipyard. Clean shipyard applies a systematic approach and complies with international region and local Service Act, the Waste Act, the Decrease and the Land Use and Construction Act, and strives to evaluate environmental aspects and prevent, reduce, and minimize the ecological impact of its activities on land, soil, and water. It includes, but is not limited to, management of the following environmental and waste management and timely response to environmental contamination aimed at controlling, monitoring, and mitigating the adverse effect on the yard's operation. The key elements of the clean shipyard in shipbuilding are the 3 R's, as shown in the figure. In order to properly implement the 3R approach in the figure, all the resources involved in the yard's operation should be divided into 2 processes, namely a production process, which includes resource and energy used directly in the production of the ships, and support processes, which includes resources and energy used indirectly in the production of ships. The criteria of the minimization, recovery, and reuse should be paramount for the resources involved in all production and support processes, aiming at eliminating waste in a clean shipyard. However, in the case of waste discharge, the waste types should meet the requirements of environmental friendliness, recyclability, and reusability. Based on this approach, a clean shipyard can be defined a shipyard which is considered to be absolutely clean when all production and supporting process in the manufacture of the ship have zero environmental impact. To achieve a clean shipyard, manager can design, develop, and implement various types of management frameworks such as environmental management, waste management, water management, etc. Green shipyard. As shown in the figure, and given the energy-intensive nature of the shipyard, the degree of energy consumption is considered to play a crucial role and to take an important place in the evaluation of the criteria for a green shipyard. The criteria for energy consumption and the ability to exclude pollution types of energy, therefore, seem to be cornerstone of the green yard concept, highlighting the role of energy and importance of reducing, eliminating polluting emissions can raise awareness among society, yard managers, and policymakers. Green shipyards should undeniably strive to minimize energy consumption and associate polluting emissions as well as emissions of non-energy related resources such as volatile organic compounds from coating and paint, and dust from surface treatment, cutting, and welding. Therefore, green yards should consist of three main principles in the energy chain, namely production, consumption, and conservation. The main elements and objectives of green shipyard can be illustrated in the figure. The 3E approach, which is called trias energetic or based on energy, environment, and economy, shown in the figure not only reduce air emissions, but also contributes to the design and implementation of transdisciplinary environmental framework to promote socio-economic criteria for sustainable development. To achieve such green yard strategy, energy source must be used as efficiently and sustainably as possible to minimize polluting emission and improve air quality through a near zero or zero emission pathway. Based on 3E criterion, the definition of a green yard could be: a yard is considered to be fully green when all production and support process in the production of the ship have zero air emission. Now we are entering to second poll. I will be grateful if all attendees contribute to this poll. The question is that, which of the following is most important for reducing air emissions from shipbuilding? Technology and innovation, human factor, operation, economics, policy and regulation, or all have the same importance? In addition, if you think that other areas need to be taken into account, please indicate so in the chat section. Thank you very much. I'm repeating again the question, and I will kindly ask participants to attend to answer this question, which will help us for further analyzing. We provide 5 disciplines. Yeah. Thank you. We will continue the presentation. I will kindly ask my colleague, okay, we remove this one and we will proceed. Slide. Energy management framework and energy management system. The figure shows energy management framework and energy management system and their specific components. Although each discipline has its own tools and measures, they are interconnected, intertwined, and interact with each other, and some measures may even be common to different criteria. The framework has been designed in a systematic way. This means that in order to solve the problem, we look to the energy through the perspective of other stakeholders, replacing one-dimensional thinking with multidimensional one. Since energy is categorized in the socio-technical system, it is important to consider the solution, that is technology, in the related environment and social context. Energy management framework is a transdisciplinary framework and helps to bridge socio-technical aspects, and a variety of perspectives, methods, and models can be used to summarize the improvement of energy efficiency in shipyards. Therefore, based on the systematic literature review, different sustainability theories, experimental experience, and interviews with experts, it can be understood that the 5 disciplines of human factor, technology and innovation, policy and regulation, operations, and economics are the main disciplines for improving energy efficiency in shipyards, and the framework is consequently based on the 5 mentioned pillars, which complemented each other, and each of which contains different measures and tools, support and promote energy management framework. The human factor was chosen as one of the disciplines in the framework because within the complex socio-technical system and shipbuilding sector, and with reference to the fact that human system has crucial role in sustainability, it is an important factor in transforming and redefining technological progress. Technology and innovation was chosen as another discipline within the framework. It is important for sustainable energy transition that is necessary includes social technical aspects as well as impacts on changing market requirements and the developing shipping cluster. In line with this, shipyard operations were chosen as another column in the energy management framework, as it can potentially affect productivity, efficiency, and labor needs in shipyards. Policy and regulation, including environmental regulation in different cross-sectional, international, regional, national, and local, is one of the most important factors in helping the shipping industry to achieve its ambitious goal of significant and the rapid reduction of carbon emissions and the socio-technical transition of the sector. Finally, economics factor and analysis were selected as a fifth discipline of the framework because of their important role in decision-making and competitiveness of the shipyard and maritime cluster. Another important feature of the framework is its dynamic nature. This means that the framework is continuously updated on the basis of feedback and results from implementation, and the new benchmark and requirements are set accordingly. The dynamic vision can be achieved by following the PDCA Plan, Do, Check, Act cycle. The sequence of PDCA cycle that make the framework a living document. This characteristic of the framework leads to continuous improvement and adaptation. Adoption of energy management framework. Innovation means introducing any new idea, material, policy, measures to a system to improve productivity and efficiency. The most critical factor for the success of any innovation is its adaptation. As shipping is a complex criterion with the engagement of multi-actors, any innovation must be accepted by the relative social group. There are different types of approaches to innovation. The linear process is about introducing the innovation to problematic criteria until to solve the problem. However, in the energy system, the process is more complex and does not occur through the linear approach. The innovation must be adopted by the end user as well as be supported for both marketing and seeking user acceptance. Furthermore, the innovation must be adopted in different phases and multi-level models from micro level with abrupt change to macro level with long-term changes. The energy management framework is an innovative instrument in the socio-technical system to support the decision supporting system in shipyards operations in order to manage energy consumption and provide decision makers with a framework to make a simple, rational, and optimized decision in a complex atmosphere. As the framework is a niche at the micro level, it is essential to be supported by society till the energy management framework be adopted by the related social group, which is the shipbuilding industry. However, as flexibility is one of the attributes of the framework, it can be designed and developed for other industry sectors. The figure shows the adoption process of the framework within 3 different levels of micro, which is niche, meso, regime, and macro landscape. The energy management framework is an innovative measure and is placed at the micro level of adoption. In order to be adopted, it requires more time and effort. In the regime, the stakeholders in shipbuilding define their priorities, aims, and goals within a structural format, as much as the multi-actors' priorities in different systems, such as human element, economy, policy, technology, operation, are homogeneous, the adoption takes less time and energy. Meanwhile, the landscape in different criteria, such as climate change, competitiveness, and human health, act as the main driver to affect and pressure the direction of investment and introduce innovation in both meso and micro level. Furthermore, the growth of models, S-curves, in the maturity of the innovation is essential to make the progression evolutionary. It consists of 3 different phases of infancy, rapid growth, and maturity. And in each stage, there are opportunities and threats for the energy management framework. Using the Developed Energy Management Framework Plan, a case study was carried out for some shipyards. However, we will present the result of one of the studies. Through in-depth interviews with the managers of the yards concerned and based on the Developed Energy Management Framework and using multi-criteria decision-making method, the best options in 5 defined disciplines were identified and ranked according to the priorities set by the yard manager and the yard portfolio. Renewable energy and digitalization were selected and identified as the priorities of the yard directors to move to decarbonization. In this respect, a feasibility study was conducted. In the next slide, we will discuss the results and analysis. Refer to result of energy management framework, digitalization and using renewable energy become the first priority of the case study, which was a European shipyard. In this regard, a microgrid was designed and feasibility study for 6 different scenarios were conducted. As table shows, case 1 was PV cell and case 2 was using wind turbine. The feasibility study was carried out with regard to wind and solar energy for the case shipyard. Due to size and design of the yard, there was a limitation for installation of solar panels and wind turbines. The analysis shows that the annual electricity production from solar energy can cover around 60% of the annual energy demand of the yard, and that this is 43% for wind power. The economic analysis showed that although levelized cost of energy, LCOE of solar energy is $0.053 per unit of energy, and the payback period is 6 years with an internal rate of return of 11%, the LCOE of wind energy is $0.195 per unit of energy and has a negative MP of 25 years, making it not cost effective to exploit. The system has 5.53 tons of CO2 emissions annually. If the yard used solar energy, the annual electricity cost and emissions will be reduced around $361,000 and 1.34 tons of CO2 annually. The case 3 was PV cell and using diesel generator in the isolating mode. The system is combination of photovoltaic system and generator to supply the electricity to yard. The system includes 3 generators of 1 megawatt and 1.5 megawatt photovoltaic system. The LCOE of the system is $0.491 per unit of energy with a renewable energy share of 4.5%. The system emissions are 4.32 tons of CO2. The IRR of the system is around 11% with discount payback of 9 years. Case 4, wind turbine and diesel generator, a standalone mode. The optimized system in this case include a wind turbine with capacity of 1.5 megawatt and 2 generators of 1 megawatt. The LCOE is $0.348 per unit of energy if 34% of the electricity generation comes from renewable source and the system produced 2.92 tons CO2 per year. The case 5, PV cell, wind turbine, and diesel generator, again, it is a standalone mode. The optimized system is a combination of 1.5 megawatt photovoltaic system, 2 generators with capacity of 1.1 megawatt, and a wind turbine with capacity of 1.5 megawatt. The LCOE is $0.380 per unit of energy. The system produced 3.18 tons CO2 per year. The IRR of the system is around 10.5%, and discount payback period for design system is around 12 years. And the last scenario, case 6, is PV cell and wind turbine and diesel generator, but this time is grid connected mode. The system is a grid-based system that includes solar cells, wind turbines, and generators. The optimal system size for this case is combination of solar PV system with capacity of 1.5 megawatt, a diesel generator with capacity of 1 megawatt, and a wind turbine with capacity of 1.5 megawatt. The general energy production remains on standby and cannot support the microgrid, and can support the microgrid to provide additional load if needed. The LCOE for the system is $0.109 per unit of energy and produce 3.35 tons of CO2 per year. The IRR of the system is 29% and discount payback is 3.5 years. In conclusion, in the standalone grid mode, case 1, PV cell with NPC of $2.87 million, LCOE of $0.053 per unit of energy and IRR of 11%, and discount payback period of 6 years is the most economical off-grid. And case 6 with LCOE of $0.109 per kilowatt hour, highest IRR around 30% and shortest discount payback 3.5 years is the best design after case 1. In conclusion, we can say that cooperation between stakeholders is essential to promote zero-emission shipping industry. Industry must be proactive in reducing carbon emissions throughout the life cycle and not wait for it to become a legal obligation. It is important to change the attitude of policymakers toward life cycle aspect of reducing CO2 emissions from shipping. One-dimensional thinking needs to be replaced by holistic, systematic, and interdisciplinary thinking to break down the silos between different disciplines. It is essential to implement a holistic, transdisciplinary approach to addressing the maritime industry's air emissions. An environmentally sustainable shipyard can act as a driver for the economic recovery of shipyards and promote their competitiveness in the market. Now, as I mentioned, we are going to repeat the last 2 polls. I will be grateful if all attendees attend to answer these questions. It will help us in future to compare your idea about these 2 questions, because these 2 questions has been raised in the first session of the polling. Now we would like to see that whether your idea has been changed or not. The first is IMO recommended to take into account in this policy the mitigation of air emissions from shipbuilding phase. Yes, in short-term period. Yes, in mid-term. Yes, in long-term, and no. And the second is, are state governments recommended to take into account the reduction of air emissions from shipbuilding phase in their policies, like national determined contribution under Paris Agreement? Yes, in short period. Yes, in mid-term period. Yes, in long-term period, and no. I will be grateful if attendees answer to these 2 questions, which, as I mentioned, help us for further analyzing, and we will see that whether your mind has been changed about these 2 questions or not after this presentation. Yeah, we can have around 30 seconds to wait for answering this question from the participant. Your answer will help us in further analyzing and further study in this topic. So kindly ask you to answer these questions, which will be grateful to us. Okay, thank you very much. Now, thank you very much for your attention, and you can see more research about the topic, the papers which has been published by our team at Maritime Energy Management, a specialization at World Maritime University. If there's any further questions, we will be ready to answer your questions, and thanks for your attention. Professor Olcha, the floor is yours. Thank you.
So thank you very much, Captain Vakili. And if there are some questions from the participants, we are happy to answer those. Yeah. I remember while we are waiting the questions, I remember at the very beginning, 2 gentlemen already provided some input, which is very useful and constructive. And collaboration, global cooperation was highlighted, one of the participants, as well as the role of the importance of the flag states. Thank you. At the very beginning, why?
Okay.
No, that's okay.
Okay.
It's a comment. So any question, please, in the chat?
In the question section, actually, there are some questions.
Let me see, just a second. Yeah, Professor, okay. Let me see.
Thank you very much for, can see in the chat also an important component. You talk about collaboration with stakeholder. I think it's crucial in order to reach and also to, let's say, targeting the different stakeholders. So the stakeholder consultation is an important process, but also I would say a joint venture with the different kind of stakeholder that collaborate in the shipyard. So for instance, a ship owner, shipyards, a ship design, it could be a very good driver in order to maximize the cost and the financial burden. So I think the stakeholder consultation is one of the pillars my colleague Kapitan Vahid mentioned in the last slide. So I was very pleased to see these keywords. So thank you very much.
Perfect. Thank you very much for your nice comment. I think that Professor Ballini already answered to this question. As you mentioned, governments crucial. One of the things that we have to consider for anything and approach in this regard is a stakeholder analysis. When we're talking about the sustainability, we have different theories regarding the sustainability. If we want to mention some of the most important, the corporate social responsibility, corporate sustainability, green economic, and one of them is a stakeholder analysis. When we're doing the stakeholder analyzing, we have traditional stakeholders, which are usually the shareholders, the suppliers, and so on, and the new version of stakeholders, which are governments and NGOs or group or individuals of which are interested about the environmental aspect. So the governments play a crucial role. They are the stakeholders. By applying the correct policy and regulation can promote sustainability in the society. And we consider also Shipyard as one of the important firms in any shipbuilding society. So I think that the government plays a crucial role by giving incentive, applying different rules and regulations. They can change the trend of investment in any industry and in society, and in the higher level of decision making might be in the national level. Thank you. I think that I hope that I could answer to this question. There's another question, I think it's from anonymous attendee. Yeah, okay, you will. Okay.
So some of the questions regarding recording, but my colleague already highlighted. So there it will be posted as part of a YouTube video. The one question from Mr. Yilmaz: what do you think about alternative fuels and batteries on ships? Definitely, Mr. Yilmaz, alternative fuels and batteries or the electrification are one of the way forward for the decarbonization of international shipping. But in our context, when it comes to ship production, and still they can play an important role, the alternative fuels and the batteries on the ship production side. My colleague already touched upon this, and when he highlighted the green shipyard context. But do you want to add more, Captain Vakili?
Yes, thank you. Thank you very much for your answer and comment. As I mentioned, we are talking about the sustainability during the process of the shipbuilding industry. However, when we did our research, we understood that there is lack of scholars and research about the sustainability in the shipyards, and most of the studies were single-dimensional thinking. One of the most important thinking that mentioned about this and claim about the sustainable shipyard is that the shipyards are trending to using green technology on vessels, which the effect of this investment and this sustainability is in the operational phase. But as you mentioned, one of the most challenging, one of the most important thing is that shipyards consider the trends of the policies and regulations and require of the market. We refer to IMO's regulations and greenhouse gas, initial greenhouse gas strategy, alternative fuel, and the batteries and the different type of energies which can reduce emissions from the ships is very important. And the shipyard which has this ability to have this technology and provide this technology for the ships which has been produced in the shipyard has an advantage and the competitiveness advantage in the competitive market. And one of the most challenging and the barriers which exist is uncertainties about the timing and the type of the fueling transition in the shipyards. That is a big challenges for the ship owner, that when and what type of fuel transition, what type of fuel should be used for the new order vessels. Thank you. There is another question. Before these two questions, I will back. Thank you very much for a nice comment about the presentation. How have choose the disciplines of the framework? It's really a little bit tricky question, and it takes a lot of time to explain. But if I want to make it short, when, as I mentioned, when we wanted to create a framework, we were in doubt that what type of the methodology we have to apply and what type of approach we have to consider. We could have a theory framework or conceptual framework, but after research and study, as I mentioned, there is lack of a study about the sustainable shipyards. We understood that we understood that we have to consider conceptual framework, because when we back to the conceptual framework, it is that we have to justify why we have to use this study and what will be add to the information and knowledge in this field. And the other thing that we had to consider in the conceptual framework is that we have to provide the methodology. So at the beginning, we consider objective deductive approach, which is top to down approach. It means that we try to identify the disciplines through literature review. As I mentioned, there is lack of a study in this regard, so we consider other industries, heavy industries, which has similarity to the shipyard, and we figure out and list the measures and tools which has been used to improve sustainability and which criteria they have been considered. Unfortunately, most of the studies were single dimensional thinking, so we gather all information and those measures and tools and we classify. In order to increase the validity, we consider triangulation approach, and we in this time we consider the subjective inductive approach. It means that is bottom top approach from data to the creating the conceptual framework. And based on these studies and based in this achievement, we understood that all measures and tools can be classified under these 5 main disciplines. As I mentioned, it's a very big discussion. I hope that I could answer to your questions. Thank you.
There is a good question from Mr. Tuan Dong regarding when we implement energy management framework, whether we can also reduce the local pollutants like the particulate matter. Mr. Dong, definitely the answer is yes, but Captain Vakili can elaborate more on this.
Yeah, thank you very much, Mr. Dean, for your good question. As you mentioned, yes, I think that one of the features of the framework is its flexibility of the framework, because we have considered different disciplines We try to have a holistic, systematic approach. When we are talking about the systematic approach, it means that we look at the problem, which is energy efficiency matter, through the perspective of other actor players. So we classified in the holistic approach, we considered the idea of different stakeholders in this regard. And the framework also, as you mentioned, has this capacity to reduce the particulate matters and air pollutant, which is very important to improve human health. Yeah.
There's another very good question from Mr. Mehmet Tantan. So did we consider effect of green supply chain management to the sustainability? Before giving the floor to Kaptan Vakili, when it comes to decarbonization or air pollution reduction from any operation, either on board a vessel or in a shipyard, and definitely energy chain, supply chain, and the life cycle dimension has to be part of it. Otherwise, basically what we do, we basically shift the problem from one domain to the other domain. But let me give the floor to Mr. Kaptan Vakili to elaborate more.
Thank you, Professor Olcher, and thank you, Mr. Tantan, for your good questions. Yes, in this webinar, we already explained about the formation of the energy framework and how it has been developed and how it has been considered. But in our further analysis, we consider and we classify the energy sector in the shipyard, and we classify the energy sector to the supply chain system, to economic system, and to ecosystem. The supply chain system is embedded in economic system, and economic system is considered in the larger, broader area, which is ecosystem. And on that analysis, we consider also supply chain management, and we consider supply chain management regarding the sustainability. And it's very important that green supply chain system to promote the sustainability. But the other thing that I have to highlight that energy management framework is a flexible and can be adopted and can be changed based on the request of the decision makers. It has this flexibility that can be adopted by the decision maker priorities. For example, we did 6 case studies from different parts of the world with different size of the shipyards. And during this interview and during this analysis, we could adopt and change the framework based on the priorities of a decision maker with respect to the size of the shipyard, geographical location of the shipyards, and portfolio of the shipyards. And it depends on decision maker whether they want to implement this sustainability, they create the borders of the sustainability. The sustainability is a very complex phenomenon, and the human element is the place at the center of the sustainability. So it might be different from case to case, from individual to individual, from region to region. This framework has the capacity to be adopted based on the request of the decision makers, but in the holistic approach, we consider green supply chain, and it's very effective for improving the sustainability in the shipyards. Thank you.
There's another interesting question, and Mr. from Farooq Ali. Sustainable development is quite challenging for developing countries, which is absolutely correct, Mr. Ali. And there is a need to mutual cooperation of international community. That is a very valid point. And that's why Kaptan Vakili, can you please elaborate more on this?
Which question, Professor?
Can you please scroll up a little bit?
Which stakeholder should be held accountable for emission?
No, a little bit scroll up, Mr. Farooq Ali, up.
Mr. Farooq Ali, okay, sustainable.
There is need to mutual cooperation of international community. Yes, Mr. Farooq Ali, thank you very much for your comment. I absolutely agree with you. As I mentioned in the conclusion, the cooperation of all stakeholders in the shipbuilding, in the shipping industry is crucial. Not only the stakeholders, but also governments and international community. As I mentioned, IMO's greenhouse gas initial greenhouse gas strategy aims to reduce emissions from the shipping industry, although they're focusing on the operational phase, but they also consider the collaboration with other stakeholders like ports. For example, they have the MBPC resolution that they provide some advice. I don't want to enter to this resolution in detail, but they have this approach that the other stakeholders should participate to reducing emission. Although IMO is regulating international shipping, but I think that they have to have a broader vision and consider life cycle emissions in cooperation of other international community, as you mentioned. Thank you very much for your nice comment, for Mr. Ali. I'm absolutely agree with you. Thank you. And Mr. Claudinos Kunze, which stakeholders should be held accountable for emission during shipbuilding phase? Shipyard, ship owner, flag step, and ship charter. Thank you very much for your interesting question, Mr. Kunze. It's a very good question. The shipping industry is a very complex phenomenon, it's a complex system. Because different participants, different stakeholders with different background, with different churches are taking part in this industry, and it's a very complicated situation, and it's not very easy to answer that which one is responsible. One of the barriers, one of the study which has been conducted, and in one of our papers that is mentioned about the identify energy efficiency in the shipyard, we highlighted and we studied that the different barriers which exist in improving energy efficiency in the shipyards. And one of them is a split incentive. Okay, we are going to improve energy efficiency, we invest from the we invest regarding reducing greenhouse gas emission and improving energy efficiency, but at the end, who will benefit from this one? So it's one of the barriers that should be studied further, and we have to consider might be different from case to case, and it needs cooperation and collaboration of stakeholders. And this is the reason when there is a complexity situation coming, when there is different stakeholders with different background, and even the priorities and the benefits are conflict with each other. In this regard, we have to consider transdisciplinary approach or interdisciplinary approach to solve the problem. I hope that I could answer to your question. Yeah, is there any further question?
I think with this, there is no further question. So I would like to take the opportunity to thank all the participants on behalf of my colleagues for your presence and for your time despite your busy schedule, especially for your input and constructive comments. And definitely the video will be shared in YouTube, the WMU YouTube channel. And also the presentation will be also shared by the participants. So you might be able to write to us for any further questions or clarification you might have, myself, my colleague, and then Kaptan Vakili. So from my side as the moderator, thank you very much, but also let me give the floor to my colleagues for further or final comments, please.
Thank you very much for this very, very fruitful discussion and with the different questions. I think we touch upon a different, let's say, key point. One of that was the collaboration, I still call the collaboration. I would say also the leadership from the shipyard itself, right, in terms of a priority in energy reduction, environmental reduction. So I think it was a very good a fruitful opportunity on that. So I really thank all the participants and my colleague too. So thank you very much.
So Pete, can you please launch the results so that Kaptan Vakili, before closing the session, can, Kaptan Vakili.
Yeah.
Sorry, I was mute. I really apologize. The third question shows that the 47% predicted it will increase, which is correct answer, because we discussed that with respect to the trend of the industry to reducing emission from operational phase. If we don't pay any attention to the shipyard, it will increase. Our policy makers recommended to take into account the life cycle emissions. Interestingly, 87% believe that it should be considered. Thank you very much. I'm really happy to see this answer. And about the IMO, 30% believe that IMO should not be taking action. And interestingly, that yes, long-term period 38%, and after that we have medium-term period and 29% the short-term. The government should take action. Again, 30% no, and majority believe that the government should take action, and as well as IMO. Now, if we proceed further about, would you please share again, Pete? Sorry, it has not reached. Okay, this is okay. Yeah, absolutely. Thank you. 41% believe that technology and innovation is very important. And after that, we have policy and regulations. It's very important, as you mentioned. And economics, and it's interesting for me that economics only 16%. However, our research shows that economics is very important for the shipyards and play a crucial role, and also operational phase. 40% have the same importance, believe that they have the same importance. As I mentioned, it might be different from case to case, from shipyard to shipyard, and depends on the decision maker at the shipyard. Can we go to next round of the, yeah. Okay, interestingly that you see that from the IMO actions, it has been increased. It was 30% that said no, now 39% believe that they have not to be considered by the IMO. And regarding the government, from 30%, it's become 4%. So more people believe that governments has more role and they have to take action in this regard, and in the midterm measures or short-term or midterm measures. Thank you very much. I'm really grateful from the audience that you attend to this webinar. I hope that it could be useful for you.